You give an AI agent a complex prompt, and a dozen things happen at once. It reads files, writes code, runs tests, and fixes its own mistakes in real time. This speed creates a powerful efficiency argument. The machine never gets tired, it never loses its place after a context switch, and it won't stop to check its phone halfway through a massive deployment. When we watch a system flawlessly execute these highly bounded, short-term tasks, it is incredibly tempting to assume it can handle unbounded, massive-scale projects. We see it fix a single script, and we assume it can design an entire architecture. You watch it chain together a successful workflow, and you inevitably start to wonder why human oversight is even necessary in the loop anymore. This diagram represents how the tech industry measures progress. It's framed as a straight line from 0% independence on the left to a fully autonomous 100% on the right. Right now, every major company is sprinting to that right edge. Technologist Sunny Bever points out a severe flaw in this logic, taking a system that excels at defined tasks and stretching it to manage complex, open-ended systems ignores how the machine actually functions. Treating maximum independence as a guaranteed upgrade sets us up for cascading, compounding system failures. Computation processes inputs according to strictly established rules. Artificial intelligence handles this flawlessly, but judgment is about deciding which rules actually apply, determining which inputs matter, and knowing exactly what sacrifices are acceptable to reach a specific goal. You see this tension when an AI refactors code. It might produce something mathematically optimized, but completely unreadable to the human developers who maintain it. It's the equivalent of designing a structurally flawless support beam that perfectly blocks the only doorway. The machine made no mathematical error in these scenarios. It simply lacked the necessary context to know what human metric was actually being optimized. Total independence fails because it mistakenly attempts to solve a highly nuanced, subjective judgment problem with brute force computation. Working closely with these systems acts as what Bever calls the silicon mirror. Having to explicitly explain your intent to a machine forces you to confront how vague or contradictory your own reasoning actually is. Removing yourself completely from the process shatters that mirror. You stop clarifying your thoughts, becoming a passive rubber stamper who just clicks approve on an output. We have seen the dangers of automation complacency before. When commercial pilots let autopilot handle routine tasks, their reaction times dull, and they lose their sharp edge during sudden system failures. Fully autonomous systems eliminate human involvement, simultaneously degrading the exact capabilities required to step in and correct the machine when it fails. That straight line from 0 to 100% is an obsolete way to manage artificial intelligence. Instead, Bever proposes mapping tasks onto this grid. The horizontal axis measures the reversibility of an action, while the vertical axis measures the clarity of the success criteria. If a task like formatting or automated testing is easily undone and has obvious success metrics, you can let the machine run completely on its own. If an action is hard to undo, like a production database migration, but still has clear criteria, the machine can propose the work, but a human must definitively approve it before it ships. For anything involving architectural choices, product decisions, or subjective goals, the human remains deeply in the loop as the primary decision maker. True operational efficiency is never found in a fixed state of independence. It requires dynamically shifting control back and forth based entirely on the cost of a mistake. Peak output relies on the specific collaboration pattern built between human and machine. The industry's singular quest for maximum independence optimizes for human removal when it should be pursuing human amplification. The ideal state is continuous, dynamic synchronization. The machine handles the pattern matching and heavy lifting, actively supporting human intent without ever replacing human responsibility. Reject the ease of blindly handing over the wheel. Build your own operational framework, because choosing exactly when to use artificial intelligence is the ultimate human judgment call.